Okay, here we go for part 3, and this is actually the last example. I thought there was 2 more examples, but this is the last one, and it is a doozy. So let's get into it. Um, Hopefully you've read the question. This idea of we've got a function that models the spread of a rumor, and t is the number of days, and n at t is the number of people who have heard the rumor. So assuming that every student of the school will eventually hear the rumor, determine, I, the number of MCV4U students who started the rumor. So this is um, like the initial number of students, right? So this is n at 0, and n at 0 is just 800 over 1 plus 39 to the exponent e to the exponent 0, which is just 1. So this is 800 over 40, which is just 20 students. Okay, the student population of the school. So this is everybody, right? So this is, as t goes to infinity, we know that n at t will go to the number of students, right? Eventually everyone will know. So what we're asked for here is the horizontal asymptote. So let's think about it. The limit as t goes to infinity of 800 over 1 plus 39 e to the, well, as t goes to infinity, e to the exponent negative t, what does it do? Well, this is a decay function, right? If this is y equals e to the minus t, it goes to 0. So this goes to 0, which would mean this goes to 0, which means this is equal to 800 students, right? And so that means the horizontal asymptote for later, right, for when we have to sketch the graph, is y equals 800. Check, check. How long will it take half the kids to hear the rumor? So half the kids then would be 400. So we want t so that nt equals 400. Okay, notice there's not a lot of calculus. I suppose this part's calculus, but we haven't taken a derivative yet, but this is still an interesting question compared to the business one that we just did, or the scooter one. I find this a little more interesting. Um, what do we got here? How do we solve this? Well, I'm going to multiply both sides by that. That thing on the bottom is never 0, so um, I can multiply 39 e to the exponent minus t, 800, expand 39 times, oh, hang on, why don't I just divide by 400 first? That's a good idea, right? Divide both sides by 400 instead of expanding. Got to think, Resto. Subtract 1 from both sides, and then I get 39 over e to the exponent t equals 1. Ln of both sides, right? T equals the ln of 39, which is about 3.66 days. So after 3.66 days, half the students will know, or I've heard the rumor, or whatever. Good. All right. Check, check. What's next? It's got to be a derivative one. The day on which the rumor was spreading the fastest. The day on which the rumor was spreading the fastest. So this would be not just the number of students, it's the rate is a maximum, right? We want how when the rumor was spreading the fastest is the fastest rate of change. So we want, for 4, we want to maximize the rate of change. We want to maximize n prime at t. So that means we need to take the derivative of the rate of change. We need to set n double prime equal to 0, right? To find the maximum rate of change. All right. Okay. We can do that. We've got to take a couple of derivatives, though. So where the original function was 800 over 1 plus 39 e to the minus t, right? E to the minus t. This one is a quotient rule, I believe. And so I'm actually going to write it as one of these babies. To the minus 1. Instead of quotient rule, there's nothing to take the derivative of in the top. It becomes 0 anyway, so it's okay to write it. Well, it's okay to do it any way you like, but this is the way I'm going to do it. Chain rule, -1 times 800, write down the inside thing. This becomes -2, and then times the derivative of the inside thing, which is 0 there, and 39e to the minus t, right? Derivative of this is just that. And then the derivative of the inside thing, I got to multiply by another -1. Okay, fine. Tidy this up. This goes to the bottom, right? -2, it's going to go on the bottom. And maybe use the quotient rule, which would have made that squared on the bottom anyway, which is okay. 39 times 800, negative 39 times -800 is this number here, 31200, and then e to the exponent -t. Notice that there is no spot where this is 0, right? Note, and we weren't asked for this, but there's no maximum. Or minimum. It's never 0. It's always, actually, we can see it's always increasing because this is always positive. So nt always increasing. Well, which makes sense. You can't unknow a rumor. All right. Now we got to take the derivative of this, which is not much fun. It is a quotient rule, so take the derivative of the top is just that. But times -1, because I got to take the derivative of the inside thing, is -1. Write down the bottom. Minus, write down the top. Derivative, running out of room here. Derivative of the bottom is the 2 comes down. Write down the inside thing. But then I got to multiply by the derivative of the inside thing, which is 39e to the minus t, and then the -1 for the inside part, all over 1 plus 39e to the minus t. That thing squared is to the exponent 4, and wow, what a mess. But I can take out a factor. You see a common factor, I hope. There's a 31/200. There's a t to the exponent, or e to the exponent minus t. I'm going to take out that, and I'm actually going to take out a minus as well. Why not? So I'm going to write that and figure out what's left. Inside is just this. Squared. That's gone. And then all of this stuff, I should have taken out, I can. I should have taken out one of these brackets, right? Because there's one there, and there's 2 there, rather, and 1 there. So I'm going to take out one of those brackets. I just noticed that. So I'm going to go back to my green so I can take out more common factor. There's 1 there, and then what's left is one of those. And then whatever's left here, I see I took that out. I'm left with I took out the minus. I'm left with a 2 times 39e to the exponent minus t. Whoops, there's a minus 1 there as well, so I got to make that a minus. Wow. All to the exponent 4. Um, so where is this a maximum? It's where this equals 0, right? So set equals 0. Well, I'm not going to get a solution from there. I might get a solution from here. I'm going to tidy this part up a little bit. Still, no solutions from that. There I get a solution, right? We actually solved this earlier. And this part in here is 1 plus 39e to the exponent negative t and minus 2 of them. So that's 1 minus 39e to the exponent minus t. I'll notice that one of these will cancel. You see that? Now that I factored that out, this is actually gone, and this becomes, there's 3 of them there. No solutions there. Set this equal to 0. No solutions there. So, but I do get a solution here. 1 minus 39 e to the exponent equals 0. I solved this already, didn't I? I think. Take the ln of both sides. Right? Take the ln, the negative t comes down, and I get t is about 3.66, which was our answer up here. Wow. Wow, wow, wow. So what does that mean? That means if I do a sketch, so by the way, the maximum rumor rate occurs after t equals 3.66. And I should check that, but I was just thinking of the graph, how this is easy peasy. Now, the graph is, because I know it's always increasing, and I know that there's a point of inflection, the maximum rate of change. It starts at 20, and it goes to 800, which is a horizontal asymptote. And after 3.66 days, it's its maximum steepness, the point of inflection, something like that. Neat. And that's at the halfway spot, which kind of makes sense. Once you get to the halfway point, the rumor spreads. Well, most of the people have already heard the rumor, so it may make sense that the rate that it's spreading will decrease because already half the people have heard it. So there we go. And this was part B here, I think, where we had to sketch the graph. Yep, lovely. This is actually, this type of function, this shape is quite often occurs in natural situations where we think of population growth as being exponential, but there's usually some sort of maximum population that, for instance, the planet can sustain. So up until this point, the Earth's population is increasing exponential, but whatever this amount is, the maximum population that the planet can achieve, then the growth rate will start slowing, and whatever the maximum amount is, it'll start evening out, and bad things will happen on the planet when that occurs, unfortunately. Logistic function, that's a funsy one.